Before we move further to the events of probability, let's us get into the definition that we'll usually use in probability, which are the intersection, union, and complement event. Okay, we look on the intersection first. When we talk about intersection between event A and event C, it tells you that there are a common number in A and C. What it means by common here is that the value can occur in A. It also can occur in C. So the intersection is represented in this area, the white area here. Okay, so it should be written like this. Okay, so look back at our event A. Event A is the even number, and event C is number is greater than or equals to 6. So here, which number that is common in A as well as in C? Here we have A, we have 2, 4, 6, 8, and 10, while C consists of 6, 7, 8, 9, and 10. So the same number that occur in A as well as occur in C will be 6, 8, and 10. So this is A intersect with C. So the symbol here is represented by this. And as for union, it tells you the information that number has in B and or D. So I can illustrate the information for union as like this. It can have in B or and D. Okay. So it represents by this information, and the symbol for union will be like here, or sometimes it's written as or. Recall back, the event for B is the odd number, and the event for D is 3 and 9, and both is odd number. So the union between B and D, the union between B or D, the union between B and D the union between B and D is written as this, and the element inside B union D will be 1, 3, 5, 7, and 9. Okay, so D consists of odd number 3 and 9. So this is the results for B union D. As for complement events of B, it tells you the information that's not in B. Okay, what is not in B? The white area here is not in B. So what is B? B is the odd number. So what not in B? So not in B will be the even number. So I represent the complement event by B prime. You also can write as B complement like this, or sometimes people write it as B bar. It doesn't matter. As long as the information that you denote here is represent the complement information. So the event in complement B will be even number 2, 4, 6, 8, 10.
Hi class, I want to talk about shading Venn diagrams. I found that students have struggled with this in the past, and it might be helpful to have a video to reference when you are studying. So let's say our instructions are telling us to shade A, complement, intersection, B. So there are a couple ways to think about it. One of the thoughts I had was to use colored pencils to help me out. It's not necessary, but it may be a visual helper. So the first thing I'm going to do is shade A complement. I'm going to start by breaking it up. Let's figure out what is A complement, then we'll figure out what is B, and then we'll take the intersection between them. So let's do A complement first. And that's going to be everything except A. So we're going to shade everything except our set A. So try to get everything there. Okay. Then let's visualize. All right, well, what does B look like? I'll switch colors. Well, B is pretty simple. Shading the whole entire circle B. All right. Well, because I'm taking the intersection between them, I'm actually taking the overlap. Okay, so that means if I put these two pictures on top of each other, where would both graphs be shaded? Okay, so you could visualize it and say to myself, okay, I'm going to shade only the areas where both are shaded. And I might think, all right, well, I'm going to shade in black for the final answer here. So my A intersect B. All right, I might say, well, are both graphs shaded around the edges? Well, no, it's not shaded around the edges here, so I can't shade there. Okay, so nothing outside the circles. How about in region here, this only A region? Well, no, that's actually not shaded in either graph, so I won't shade there. Then what about this middle section? Will I shade here? No, I won't, because it's not shaded in A complement, but it is shaded in B. So don't shade there, because I need both of those regions to be shaded in order to shade the intersection. Well, then it brings me to this only B section. And it looks like, yes, this only B section is shaded in both graphs. So the final answer would be this half moon that looks like the B, only B. Okay, so that would be the final answer. Hi, okay, so let's do that same problem in a different way. So what if it's shade A complement intersect B? Okay, I'm going to start by shading A complement in green, and I'm gonna use less graphs this time. So I'm gonna do A complement in green. Okay, then I'm gonna do on the same graph, I'll do B in red. So all of this B section. Okay, then I'm looking at this graph and I'm saying to myself, okay, where are they overlapping? Where does A complement overlap with B? And I'm overlapping because this is an intersection. Okay, so I want where the areas on the graph where both are red and green. Okay, well, I can see that right here, this half moon again is the place where I see both red and green. That's the overlap between these shaded areas. So lastly, it's the same answer. The final answer is in black. What I would do to be very clear on a quiz or test is I would make sure that my final answer is shaded on the graph only where I want it to be shaded. I would not leave any other marks on the graph because that will be very confusing for the instructor. Okay, so that's your final answer, and it's the same answer that we got when we did it kind of the long way when we used 3 graphs. Okay? All right, let's try a union this time. So let's try A complement union B. All right, this means instead of the intersection, we are taking all of the shaded region, okay? So let's try it again. I'm going to start with A complement in green. And you've seen this before. Everything except A. We're going to shade all of that. All right, we know what that looks like. Let's split up and do B in this orange color. Everything in B. Everything in the B circle. And then I'm taking the union of this. I'll use black. A complement union B. All right, so I'm going to take anything that's shaded in either or graph. Okay, so because it's a union, it's either or. If it's shaded in this graph, I'm going to shade it in the final graph. If it's shaded in this graph, I'm going to shade it in the final. So it's all of the shading together. All right, so I might go region by region and think, okay, everything outside the circles, is that shaded in either or graph? And I'd say yes. In this A complement, it is shaded. So that means in the final graph of a union, I am going to shade that. Everything outside the circles. Okay. Not perfect. Okay, then I'm thinking region by region. This A only, well, is this shaded on either or graph? Actually, no. The A only is not shaded on either graph, which means I cannot shade it. All right, and then I'm thinking about the middle region. Is it shaded on either or? Well, it's not shaded here, but it is shaded here. So that means, yes, I can shade it because it's shaded on the B, and this is a union. Okay, so then I'm thinking that last region here, this only B section, is this shaded on either or graph? Well, actually, yes, it's shaded on both, so we will be shading in that B. And now I've done all the regions, and I'm complete. This is the final answer here. But I want you to think about that same problem in a different way that might even be easier. And I'm going to think of the same problem, A complement union B, and I'm going to try to do it on using less space. So this time I'm going to start again with A complement. Everything not A will be shaded. I know you've seen that a number of times. And then I'm shading right on the same graph. I figure this is a union. So everything, it will be shaded in the end. So if I shade it in A complement or if I shade it in B, that's going to be included in the final answer because this is a union, remember? So I'm going to shade all of B. And then this, because it's a union, this is actually the final answer. Okay, so final answer, if I want to be real official about it, is everything in these regions, everything except that only A section right there. Okay, so I got the same answer in two different ways. You can kind of see that. Same answer, two different ways. All right,